See what I get to look at? It's backwards. Yeah, I started to notice that it almost looks normal to me now. I don't know if that's a bad sign. We will start in about a minute. I can't see with my glasses on after all. Okay, it's 8 o'clock. We'll continue in Chapter 7, Section 5, solving applications with rational expressions. All right, here is problem 5. Lizette can mow the lawn in 3 hours, and Barbara can mow the lawn in 2 hours. Find the amount of time it takes both of them to mow the lawn together. Okay, so this is a work problem. Remember what form of equations we use for work problems. In a work problem, there's a task or a job to be completed. So the equations have the form rate times time equals 1. The 1 represents the task that they are working on. We have 2 participants, Lizette and Barbara, so we'll write down a rate times time equals 1 equation for each of them individually, but then it also mentions that they work together, so we'll have a third equation of the form rate times time equals 1 when they work together. So for Lizette, let's write down an equation of the form rate times time equals 1 for Lizette. This first part of the first sentence says Lizette can mow the lawn in 3 hours. So Lizette's rate, we'll refer to that as R sub L for Lizette's rate. And in 3 hours, she can mow 1 lawn. So for Lizette, there's our equation that has the form rate times time equals 1. Then we'll write one for Barbara. In the second part of the first sentence, it says Barbara can mow the lawn in 2 hours. So Barbara's rate, we'll use R sub B to represent Barbara's rate. And in 2 hours, she can mow 1 lawn. Then in the last sentence, tells us what we want to do. Find the amount of time it takes both of them to mow the lawn together. Okay, so if they mow the lawn together, the overall rate will be Lizette's rate plus Barbara's rate. And in a certain amount of time, they will mow one lawn. We do not yet know how much time it's going to take them to work together. That's what we're supposed to find. We have enough information to determine how much time it takes them to work together. So we're using capital T to represent the amount of time it takes them to mow the lawn together. So what does that mean? That means we want an equation whose only variable is capital T. Okay, so what we do, each of those three equations will solve for the rate. Lizette's rate, or Sibel, we can find that if we divide both sides of this equation by 3. Lizette's rate is 1/3, which means that she can mow 1/3 of the lawn per hour. Barbara's rate is 1/2. We divided both sides of that equation by 2. So Barbara's rate is 1/2. That means that she can mow 1/2 of the lawn per hour. And then the rate when they work together, Lizette's rate plus Barbara's rate equals 1/T. We divided both sides of this equation by capital T. Now we make substitutions. So I'll make a note of that. Now substitute. So replace Lizette's rate in this equation with 1/3. We're adding that to Barbara's rate, which is 1/2. And Lizette's rate plus Barbara's rate is 1/T. So now we have an equation whose only variable is T. And we know how to solve this. We can multiply every term on both sides by the least common denominator, or the least common multiple of the denominator. So the least common denominator is 3 times 2 times T, or 6T. Then we'll multiply every term on both sides by 6 times T. So 6T over 1 times 1/3 plus 6T over 1 times 1/2 equals 6T over 1 times 1/T. And then simplify each of those products. 6T over 1 times 1/3 simplifies to 2T. 6T over 1 times 1/2 simplifies to 3T. On the right-hand side, 6T over 1 times 1/T, the T's cancel, and we're left with 6. And then we have a simple equation to solve. 2T plus 3T is 5T. 5T equals 6. And then divide both sides by 5. T equals 6/5. And the units are hours. So 6/5 hours, or 1 1/5 hour. So that's an okay answer. It's all, you could also say 1 hour and 12 minutes, because 1/5 of an hour is 1/5 of 60 minutes or 12 minutes. You don't have to do that, but we should summarize. We'll just do this simply by writing working together. They mow the lawn, or working together, they mow the lawn in 6/5 hours. This is a fairly typical kind of work problem. You'll see other work problems that are also considered typical, but this one is one of those. The next problem involves uniform motion. This one says it took Lance a total of 2 hours to ride his bike 12 miles and run 6 miles. Lance's running rate was 10 miles per hour slower than his biking rate. Find Lance's running rate. Okay, so Lance ran 12 miles, or sorry, he rode his bike 12 miles and he ran 6 miles. The total amount of time to do both was 2 hours. And we're told that Lance's running rate was 10 miles per hour slower than his biking rate. And we're supposed to find Lance's running rate. Okay, so we'll assign a variable for Lance's running rate. That's what we're supposed to find. You can pick any letter you want to represent Lance's running rate. I'll just pick X miles per hour. Well, even though we're only supposed to find Lance's running rate, we have to use Lance's biking rate. So how should we express Lance's biking rate?
It would be X plus 10.
Yeah, it will be X plus 10 miles per hour. Since we already assigned Lance's running rate to be X miles per hour, and the running rate is slower than the biking rate by 10, the biking rate has to be X plus 10 miles per hour. Hey, now what should we do? Well, we know that Lance rode his bike 12 miles. That's the distance. And we also know that Lance ran 6 miles. Both of those together took a total of 2 hours. So let's start by writing a rate times time equals distance equation for the biking. And then after that, we'll write down a rate times time equals distance equation for running. And then we'll use those equations and the fact that the total amount of time was 2 hours to do both to come up with another equation. Okay, so first biking. Lance's biking rate, we're using x plus 10 to represent his biking rate. So x plus 10, we don't know exactly how much time it took him to ride the bike 12 miles. So let's use capital T sub b to represent the amount of time it took him to ride a distance of 12 miles. So we have rate times time equals distance. When Lance was running, his rate was x miles per hour. His distance is 6 miles. We don't know the exact amount of time he spent running, so let's use capital T sub r to represent the amount of time it took him to run 6 miles. So we have rate times time equals distance for running. We're using x to represent Lance's running rate, which is what we're supposed to find. So what do we need? Since we want to solve for x, we need an equation whose only variable is x. At the moment, we have two equations, but each one of those doesn't have only x as a variable. We have T sub b representing the amount of time biking. And in the other equation, we have T sub r representing the amount of time running. We want an equation whose only letter or variable is x. So how are we going to do that? Hey, the hint is the first part of the first sentence. What does that say?
We're looking for a total of 2 hours.
Yeah, the total amount of time it took Lance to ride his bike 12 miles and run 6 miles is 2 hours. So what does that mean about things in our equations? We're using T sub b to represent the amount of time it took Lance to bike 12 miles. And we're using T sub r to represent the amount of time it took Lance to run 6 miles. So what must be true about T sub b and T sub r? They have to add up to 2, right? It took Lance a total of 2 hours to ride his bike 12 miles and run 6 miles. So a third equation is the amount of time it took Lance to bike 12 miles plus the amount of time it took Lance to run 6 miles is 2. That's what we're told in the first part of the first sentence. Okay, now we have everything we need to get an equation whose only variable is x. So for the biking equation, we're going to divide both sides of this by x plus 10. So the amount of time it took lengths to bike 12 miles is represented by distance divided by rate, 12 divided by x plus 10. Then in the running equation, x times t sub r equals 6, we're going to divide both sides by x. So the amount of time it took Lance to run 6 miles, the amount of time is distance divided by rate. 6 divided by x. Okay, then in this equation, t sub b plus t sub r equals 2, we're going to replace t sub b with 12 over x plus 10. We add that to t sub r, which we are going to replace with 6 over x. And the total amount of time is 2 hours. So we finally have an equation whose only variable is x. It's an equation with rational expressions. So the technique is to find the least common denominator, least common multiple of the denominators, then multiply every term on both sides by the least common denominator. And then after that, solve the resulting equation. So the least common denominator is just x times x plus 10. Or you can write it as x squared plus 10x. Okay, multiply every term on both sides by the least common denominator. So x times x plus 10 over 1 times 12 over x plus 10. Then multiply x times x plus 10 over 1 times 6 over x. And then on the right-hand side, we can multiply 2 times the entire quantity, x squared plus 10x. Okay, in each of those products on the left-hand side, we're going to get a cancellation. On the left-hand side, the x plus 10 divided by x plus 10 cancels, and we're left with x times 12, or 12x. In the next term, x divided by x cancels, and we're left with 6 times x plus 10, or 6x plus 60. And on the right-hand side, distribute multiplication by 2, we get 2x squared plus 20x. Okay, we'll combine like terms, set one side equal to 0. We'll get rid of some of the clutter that we don't need, and then we'll solve the equation. So on the left-hand side, 12x plus 6x is 18x. So 18x plus 60 equals 2x squared plus 20x. Next, we will subtract 18x from both sides and also subtract 60 from both sides. So when we do that, I'll put the non-zero terms on the left-hand side. So 2x squared, and then subtract 18x from both sides. We get 2x squared plus 2x minus 60 equals 0. Notice that every term is divisible by 2. So we can divide every term on both sides by 2. And we get x squared plus 1x minus 30 equals 0. And this is fairly simple to factor. One factor is x plus 6, and the other factor is x minus 5. So in this problem, the positive solution makes sense. The solution that's negative doesn't. So x equals 5 is our solution. So Lance's running rate is x miles per hour. So we can summarize that. We can say Lance's running rate is 5 miles per hour. Okay, the setup on this one has a few components, but you just have to learn how to piece them together based upon how the information is given. So if you just work on one piece at a time, and if you practice these, then you'll get better with more practice. Okay, let's look at the next page. This one says, working together, Edward and Brent can rake a yard in 6 hours. Edward takes 2 times longer to rake the yard by himself than Brent. Find the amount of time it would take Brent to rake the yard by himself. This is a work problem. So rate times time equals 1. Those are the sorts of equations that we're going to use in work problems. In the first sentence, we're told that when Edward and Brent work together, they can rake a yard in 6 hours. So when they work together, let's write down an equation of the form rate times time equals 1. So when they work together, Edward works at a certain rate. We add that to Brent's rate. And we multiply that quantity by 6 hours. And in 6 hours, they accomplish the task of raking a yard. So we have rate times time equals 1. In the second sentence, it says Edward takes 2 times longer to rake the yard by himself than Brent. And then it says, find the amount of time it would take Brent to rake the yard by himself. Okay, so for Brent, we're using R sub B for Brent's rate. We're supposed to find the amount of time it takes Brent by himself to rake the yard. So we can pick a single variable like capital T to represent the amount of time it takes Brent to rake 1 yard by himself. Okay, what about Edward? If Edward works alone, well, Edward works at a certain rate. We can write that. Edward's rate, how do we represent Edward's time? So I'll give you a minute or so to ponder that. Between the information given in the problem and one of the variable assignments that we've already made, we can come up with how to express the amount of time it takes Edward to rake 1 yard by himself. So, anybody online know what to do?
Would it just be 2t since it's
How much?
twice? Would it just be 2 times t since it's twice as much as Brent?
Yeah, since we're using capital T to represent the amount of time it takes Brent to rake 1 yard by himself. And in the second part, or the first part of the second sentence, we're told that Edward takes 2 times longer to rake the yard by himself than Brent. So if Brent takes T hours, Edward takes 2 times T hours. Is that what you said? Yeah. Okay, so now remember, since we assigned capital T to be the amount of time it takes Brent to rake the yard by himself, and that's what we're supposed to find, we want an equation whose only letter or variable is T. Okay, so we'll do the same sort of thing that we've been doing. In the top equation, we'll solve for the sum of the rates by dividing both sides by 6. So in other words, Edward's rate plus Brent's rate is 1/6. That just means that when they work together, they can rake 1/6 of the yard per hour. Brent's rate, we divide both sides by the time, capital T. So Brent's rate is 1 over capital T. And Edward's rate is 1 over 2T. And now we substitute again. So I'll just remind you, substitute. In this equation on the top, we're going to replace Edward's rate with 1 over 2T, replace Brent's rate with 1 over T, and the sum of the rates is 1/6. So that will give us an equation whose only variable is T. The least common denominator is just 2T, and we multiply both sides by 2 times T. So 2T over 1 times 1 over 2T plus 2T over 1 times 1 over T equals 2T times 6. 2T over 1 times 1 over 2T is just 1. 2T over 1 times 1 over T is 2. 2T times 6 is 12T. So 3 equals 12T. Divide both sides by 12. We get t equals 3/12 or 1/4. Okay, let's move on to the next problem, number 8. Now this one says Corinne rode her bike 5 miles uphill and then back. The rate going downhill was 20 miles per hour faster than the rate going uphill. And it took 20 minutes longer to go uphill than downhill. Find the uphill rate. I need to go back to this problem that we did. I made a really bad mistake right here. I was thinking, this can't be the answer. This should be 1/6 instead of 6. Right, because the sum of the rates is 1/6. Yeah, so I'll rewrite that on this paper. 1/2t plus 1/t equals 1/6. So that was a really silly mistake on my part. But when I considered the answer, 1/4 of an hour is 15 minutes. And if when they work together, it takes them 6 hours, it seems a little strange that it would only take one of them 15 minutes. Right? Just doesn't make sense. So yeah, that was my error. So watch out for that kind of thing. So on this one, 1/2t plus 1/t equals 1/6. The least common denominator is 6t. So multiply every term on both sides by 6t. So 6t/1 times 1/2t plus 6t/1 times 1/t equals 6t/1 times 1/6. Okay, on the left-hand side, 6t/1 times 1/2t. 2t goes into 6t 3 times, so this is 3. And then 6t/1 times 1/t, that's 6. 6t/1 times 1/6, the 6's cancel, so we get t. So t equals 9. That seems a little more reasonable if it takes them a total of 6 hours working together. Then for one of them to take 9 hours, that's much more reasonable than 15 minutes. Okay, so let's go back to number 8. Corinne rode her bike 5 miles uphill and then back. So that means 5 miles uphill and then 5 miles back. The rate going downhill was 20 miles per hour faster than the rate going uphill, and it took 20 minutes longer to go uphill than downhill. Find the uphill rate. Okay, so Corinne rode her bike 5 miles, a distance of 5 miles uphill. And then a distance of 5 miles downhill. Find the uphill rate. So what we want are equations of the form rate times time equals distance. So the uphill rate, I'll just use x, miles per hour. And t sub u for the amount of time it took to ride 5 miles uphill. So rate times time equals distance. So x miles per hour, I'll just make a note of that. That's the uphill rate. Okay, then riding 5 miles downhill, we're told that the rate going downhill was 20 miles per hour faster than the rate going uphill. So if x miles per hour is the rate going uphill, the rate going downhill is x plus 20 miles per hour. And we'll use t sub d for the amount of time it takes to ride 5 miles downhill. We want to solve for x, so we want an equation whose only variable is x. At the moment, we have two different equations. Each one has the variable x, but each one also has a letter representing time. So we need to get rid of the letters representing time. We don't want to do anything illegal in the process, but we want an equation whose only variable is x. So how are we going to do that? The third sentence is the key here. It took 20 minutes longer to go uphill than downhill. We also have to convert minutes to hours. So what portion of an hour is 20 minutes?
1/3.
Yeah, 1/3. 20 minutes is 1/3 of an hour. So it makes sense that it would take longer to go uphill, especially given that the rate going downhill was faster. So we can say the amount of time t sub u to go 5 miles uphill is greater than the amount of time it took to go 5 miles downhill, and it's greater by 1/3 of an hour. Since 20 minutes is 1/3 of an hour. Okay, so we can convert this inequality into an equation. The larger number minus the smaller number equals 1/3. So if I subtract the smaller number from the larger number, the difference is 1/3 of an hour. Okay, so we've seen similar types of setups, even in the work problems. We have three equations. We want to use the information from each of those three equations to get a single equation whose only variable is x. So the top equation, x times t sub u equals 5, if we solve this for t sub u, divide both sides by x, in other words. So the amount of time it took Corinne to ride 5 miles uphill is distance divided by rate, 5 miles divided by x miles per hour. And then solve the other equation for t sub d, divide both sides by x plus 20. So t sub d is 5 divided by x plus 20. So the word now that I'm going to write down, substitute into this equation. T sub u, we replace that with 5 over x. We're subtracting t sub d, but that's 5 over x plus 20. And they add up to 1/3. Or I should say the difference is 1/3. Okay, so now we have an equation whose only variable is x. It's an equation with rational expressions, so we want to find the least common denominator. The least common denominator this time is 3 times x times the binomial x plus 20. Okay, so we'll multiply every term on both sides by the least common denominator. When we multiply 3 times x times the binomial x plus 20 by 5 over x, the x's are going to cancel each other out. And we'll be left with 5 times 3 times x plus 20. And then from that, we subtract 5 over x plus 20 times the least common denominator. This time, the x plus 20 factors cancel, and we're left with minus 5 times 3x. On the right-hand side, when we multiply the least common denominator by 1/3, the 3's cancel, and we're left with x times x plus 20. Okay, so we multiply everything out. 5 times 3 is 15. So multiply 15 times x plus 20 to get 15x plus 300. And then minus 15x. On the right-hand side, we get x squared plus 20x. On the left-hand side, we're just left with 300 because 15x minus 15x is 0. So we'll subtract 300 from both sides, and we'll get this equation, x squared plus 20x minus 300 equals 0. So we have a couple of minutes left. We might as well see if we can factor this, solve this by factoring. So let's try the AC method, 1 times negative 300 is negative 300. We want to find two integers that have a product of negative 300 and add up to positive 20. So we don't have to list every single factor. We can just use multiples of 10. So for example, negative 10 times positive 30, that equals negative 300. And our first pick, negative 10 plus 30, is 20. So we found the two integers right off the bat. And also remember the abbreviated AC method when the coefficient of x squared is 1. And we find the two integers. One is negative 10. That means one of the factors is x minus 10. The other factor is x plus 30. The only solution that makes sense is the positive one, so x equals 10 miles per hour. Okay, we just have a few seconds left. So the uphill rate is 10 miles per hour. You can check to make sure that it makes sense. Hey, it's 10 till, so we'll stop for now. We'll be looking at new material tomorrow.